Hello, my name is Ralph Carter. I'm a Chief Network Solutions Architect with CDI. Today I will be performing an ACI design and deployment session to support a multi-tenant service provider network. In this design, the ISP offers a managed subscription service to their customers, and in this example, that service is an application workload consisting of web servers and database servers. So we're going to tackle part one today. And in this video series, we're gonna configure a number of technologies. Regarding the tenant design, we're gonna create a two-tier application profile for both production and development, and that's gonna consist of the web and database applications. We're gonna create shared services for our tenants, so each tenant can have access to a backup resource where they can quickly back up their web or database services, as well as DNS and LDAP. We're also going to implement private external access for each tenant. So each tenant will be able to bring in their own MPLS circuit, their own MPLS customer edge router. They'll be able to bring in their own VPN gateway, whether it's a dedicated circuit or it's shared, it doesn't matter. Some type of external access, private external access that they're going to bring in and connect into the ACI fabric. We're also going to implement shared internet access for each tenant. So the ISP is providing internet services, and any of these web and database servers that need to access the internet, they're not going to traverse the MPLS or the private VPN circuit. They're going to traverse a shared internet service. And we're also going to be integrating Cisco ASA firewall cluster. So each tenant is going to get a virtual context, okay, their own virtual context of a firewall, of a Cisco 5500 series firewall cluster. And this is going to basically provide that private external access security. So their MPLS and VPN connectivity is going to have to go through a virtual context, their own personalized virtual context of a Cisco ASA. All right, just to give some quick background information, the Cisco ASA cluster is a two-node Cisco ASA 5500 active firewall cluster. We configured it already in spanned ether channel mode, and it's connected into two different ACI switches, leaf switches. So here, what you have depicted on the left side, we have 5500 series firewalls connecting into each leaf switch, and for the cluster control link, it's they're separate port channels. And there's also management connectivity into the out-of-band management network. The APIC controllers are also on that out-of-band management network. So if in the future, if we ever need to do any service graph, device package integration, we could use that out-of-band management network to communicate with the ASA cluster. And on the right side, we have a spanned ether channel. So each of these firewalls is participating in one logical connection with the ACI fabric. So what we're going to be doing is we're going to be assigning VLANs to this single port channel, and those VLANs are going to be used for inside and outside connectivity. We're not going to cover the actual ASA cluster configuration today in this video series, but we're going to cover it in another video to show you exactly how we set up the ASA cluster, how to configure it, how to get it to operate with the ACI fabric. Now, again, this is just an example, and there are many ways to skin this cat. So please do not hold me to this design if it does not fit your particular footprint. But you can always, you can apply it in different ways, right? Okay, so just to kind of go over of what we're implementing today, here's just more of like a logical view of what's going on. So what we want to do is the customer can bring in their own WAN router, their own CE. This can also be a VPN gateway. It doesn't really matter. They're going to have a connection into their own firewall to access their web and database services. Okay, those web and database services are going to be connected into the ACI fabric, and they're going to be protected from the customer WAN through this firewall, which is an ASA cluster. Then we're also going to have shared services, and these shared services are going to be available to the customer, but because the shared services are part of a different tenant inside the ASA, the ACI fabric, we're not going to need to provide any firewalling. So the east to west firewall protection of ACI is going to handle that security. Then we're going to have some internet access outbound, northbound here. That internet access is going to be provided to each customer as well as the shared services that are connected into the ACI fabric. Okay, so the design here is that the north-south firewall for the customer is going to be the ASA cluster, and then we're going to rely on the ACI fabric's whitelist security model for the east to west firewall segmentation and protection. And we're going to provide a shared layer 3 out, connecting out of the ACI fabric to get out to the internet and for traffic to come back. Okay, so let's design that architecture. What we're going to need to do is let's design our tenant common. Alright, let's see there for a second. Let's create our VRF within tenant common. This is going to be our VRF for our shared layer 3 out. That's fine. All right, so let's create our shared layer 3 out. We're going to call this shared L3 out. Okay, let's make this a little smaller. Tenant common is going to have some other services in here. So let's create another VRF. This is going to be our VRF for shared services. And we're going to need some, we're going to need a bridge domain actually for our shared services. Let's create a bridge domain there, another bridge domain, and then a third one. And we're going to be putting, well actually, you know what? We're going to change this up. We're just going to create one single bridge domain, because this is for shared services. So what we're going to need to do is now create our EPGs. Okay, and this bridge domain is going to be the shared services bridge domain. Make it a little smaller so it fits. And this EPG is going to be for backup. This EPG is going to be for LDAP. And this EPG is going to be for DNS. We're also going to be putting the default gateway onto the subnet itself so that we could actually do some route leaking out. So we're going to use the 10.1 subnet for the ISP network. So we're going to do 10.1.1.1. We'll do a /27. Just copy this here. For LDAP, we're going to do .33. And for DNS, we're going to put .65. Okay. Now, we need to get our external connectivity. So we're going to have a router. Let me get the internet connection going here. Here's our internet connection. It's going to be obviously a firewall service there. That's going to provide NATing and other connectivity. And this is going to be actually a 6500 core switch, but we're going to call it a router. And that's going to connect into the shared layer 3 out. Or actually, it's going to connect into the ACI fabric, but we're going to be setting up a shared layer 3 out, layer 3 routed domain to connect into that 6500 router. Okay, what are we missing here? We need to now create our tenant. So our tenant is going to be called customer 1. You know what, let's move this up a little bit. I believe we're going to need some room. I think we can get away like this. All right. So as far as the tenant goes, we need some bridge domains. We're going to actually create 4 separate bridge domains. In the event the customer is going to want some layer 4 through 7 services in between the EPGs. So the EPGs are going to be tied to the bridge domain. And obviously, if you're integrating layer 4 through services, for example, if you wanted a firewall between these EPGs, it has to go through a bridge domain. It's going to be an in and out bridge domain. All right, so this bridge domain is going to be called prod web. This is going to be prod DB for database. This is going to be dev web. And this is going to be dev DB. As far as the EPGs go, this is going to be prod web. This is going to be prod DB. This is going to be dev web and dev DB. So we have our EPGs, they're inside our bridge domains, and we need to put default gateways. So we're gonna use a /24 for the customer network, and that /24 is going to be 10.100.1.0/24, and we're going to chop it up and allocate it to this customer. So let's get our default gateways going. And we're going to put our default gateways on the actual bridge domain. So we're going to use 10.100.1.1/27 for the prod web. I'm just going to copy these here. Okay, so prod DB is going to be 33. Dev web is going to be 65. And database is going to be 97. So these are going to be basically the default gateways for these bridge domains, or for these EPGs, and these default gateways are going to be in the bridge domain. Alright, so we're going to need to now create a layer 3 out so that the customer can get out of the internal, out of their network to their WAN connection. So before we do that, let's just draw a MPLS connection here. So we're just going to put an MPLS connection here. I'm going to put, you know, their router hanging off that MPLS connection. It could also be a VPN gateway coming in to this data center as well. And we're going to put our ASA firewall cluster. So our ASA firewall cluster is going to be right here. We'll call this ASA virtual context 1. And actually, we're going to need to connect the customer directly into the ACI fabric. So what we're going to do is we're going to create another VRF. We're not going to use it for its layer 3 functionality, but we need to create the construct. So this will be customer 1 outside. Actually, let's change that to just outside, because it's going to be inside the customer's data center. Oops, can't get it here. There's some technical difficulty. Alright. Oh, and you know what I'm noticing? We forgot to put the VRF for the actual customer devices, or customer network. So we're going to have to put a VRF okay. And then we're going to create a VRF internal. This is going to be VRF outside. Within the outside, we're going to create a bridge domain. This bridge domain is going to be outside. Let's make this smaller. This is where the firewall and where the the customer routers are going to connect to physically. So we're just going to be extending EPGs. So this router, before I make that, let me put the EPG in. I'm going to call this EPG firewall edge. All right. So basically, the customer router is going to connect into this EPG. And so will the ASA cluster. So basically, this is going to be the outside interface of the ASA, and the outside interface of the ASA is going to have connectivity to the actual customer MPLS or VPN or whatever type of device that they want to connect into the data center or into the ACI fabric. All right, so let's create our layer 3 out. We're going to put that layer 3 out there, and we're going to call it ASA cluster inside. Okay. And then our inside interface of the ASA is going to connect into, it's going to be our layer 3 routed connection into the customer tenant. Okay. So regarding IP addressing, so we'll just label this as inside. Regarding IP addressing, we have the IP addressing squared away for shared services, for the customer bridge domains. So what am I missing here? Okay, so we're going to need some IP addressing for the firewall. So we're going to use the 10.100 because this firewall is going to be for the customer. Let's IP it as the customer. So we're going to use 10.100.1. Let's do 240/29. So that's going to be our inside connection. Do 243 as the firewall, and we'll do, let's do 241 through .242 for the layer 3 out. And the reason why I'm using 241 and 242 is because we're going to be routing over VPC, and the firewall is going to be connecting, it's going to be routing with both leaf switches, and it's going to be doing dynamic routing. We're going to do OSPF. We're going to do OSPF between the ASA inside interface and the customer tenant, and then we're going to do BGP from the firewall, customer firewall, and their edge router. So let's get the IP addressing down for the outside interface. Let's do 10.100.1.224/28. Let's make it a little larger than a /27, just in case the customer wants to bring in more devices, so we have enough IPs. So the customer router is going to be 225. The ASA is going to be 238. And like I mentioned before, we're going to do OSPF. Let me change that color. We're going to do OSPF on the inside, and we're going to be doing BGP on the outside. Let's get some AS numbers. So we'll use AS 65101 for the ASA, and we're going to use AS, let's pick 777 for the MPLS connection. Okay, now we're going to need loopbacks for each leaf switch for OSPF. So let's keep it to the 10.100. Let's do 10.100.1.254 and 10.100.1.253. Those are going to be our loopbacks that we're going to set on the leaf switches for OSPF. Okay, we're going to need to get some IP addressing for our shared layer 3 out here. So we're using the 10.1 for the ISP network. So let's do 10.1.1.224/28 for the outside connectivity. Here we go. Let's do 225 for the DMZ switch, and let's do 227 for the shared layer 3 out. Now we're not going to have a VPC connection on the into the ACI fabric from the outside external 6500 router. It's just going to be a single link connecting into the ACI fabric. As far as BGP goes, we're going to be running BGP off of the shared layer 3 out with the 6500. So we're going to use AS65050 on the 6500. And we're going to use, and we're going to use AS65101 for the internal network. So the customer, or actually the ISP tenant common network, is going to be 65101. The customer tenant is going to be 65. Let's see, we got to change that up. So why don't we do 65100 for the ISP, and then 6501 for the first tenant. Let me just update this diagram a little bit. We're going to be using this as our blueprint. Tenant common, tenant customer 1. We got VRF shared services here. We got VRF internet. We got VRF internal, VRF outside. We got our layer 3 ASA inside, layer 3 out. We have our shared layer 3 out. We have our bridge domains. We have our EPGs within our bridge domains. For shared services, we have our default gateways defined on the EPG itself. And in the tenant customer 1, we have the default gateways defined on the actual bridge domain.